Welcome back to the Akbar Academy podcast, where we explore the science that powers our universe. And today, we're diving into something we all experience constantly: motion.
Motion, it's everywhere, right? From galaxies colliding in space to a leaf drifting in the breeze. What's truly mind blowing is that all of it, big or small, follows the exact same mathematical rules.
That's such an amazing way to look at the world. Actually, I was watching a hummingbird outside my window this morning, and I learned they flap their wings up to 80 times per second. That's motion at a stunning scale.
Love that example. And it brings up a good question. How do scientists even measure motion that fast or that small?
Right? It's wild that something as dynamic and complex as motion can be boiled down into neat equations. But it can, and that's what makes physics so powerful.
Let's start with the basics. Speed versus velocity. People often use the words like they mean the same thing, but in physics, there's a huge difference.
Exactly. Speed is a scalar quantity. It only tells us how fast something is moving. But velocity is a vector quantity. It includes both speed and direction. So going 100 kilometers per hour isn't the full story. You need to know where you're going to, like 100 kilometers per hour north.
It's a lot like GPS, right? It doesn't just say go 60 kilometers per hour, it tells you which way to go.
That actually reminds me of astronauts docking with the International Space Station. They have to be precise not just with their speed, but their direction too. A small error in either could mean missing the station by miles.
And the best part? The same equation that helps astronauts align with the ISS, velocity equals distance over time, also works for something as simple as a child rolling a ball across a floor.
That's what I love. These ideas scale perfectly, from space travel to playgrounds.
Can you give us a quick real-world example using that formula?
Sure, imagine a car travelling at 20 meters per second for 70 seconds. Multiply those together and you get 1400 meters, or 1.4 kilometers. But here's the kicker: that car could take any path and still end up 1.4 kilometers from where it started. If it makes a U-turn or a loop, the velocity would reflect that change in direction, even if the speed stayed the same.
So the path matters when you're looking at velocity, not just distance.
Which brings up another point. How do scientists track all these different motions in experiments or real-world studies?
That's where distance time graphs come in. These things are like motion's fingerprint. A straight horizontal line means the object isn't moving. A diagonal line shows constant speed. And a curved line, that means the object is accelerating or decelerating.
So it's like a visual language of movement. You can see the story of how something moved.
That's such a great way to put it. And you can read these stories mathematically too, right?
Exactly. The slope of a distance time graph tells you the speed. The steeper the slope, the faster the object is moving. And when we switch to a speed time graph, the area under the curve actually gives us the total distance traveled.
Wait, so if you graphed a car speeding up and then slowing down, the shape under that curve would literally tell you how far it went?
Spot on. It's like a physics version of a decoder ring. You just need to know how to read it.
I'm really starting to see how all this ties together. The formulas, the graphs, the real-life examples, they're not separate ideas. They're all connected.
And I think that's what makes motion so fascinating. It's not just about numbers. It's about how we move through the world, literally.
Exactly. Whether it's a hummingbird flapping its wings, a car cruising down a highway, or a satellite adjusting its orbit, all of it follows the same elegant rules of motion.
And understanding those rules gives us a new way to see everything, from our everyday commute to the movements of planets light years away.
We hope this gave you a whole new appreciation for something you experience every day, because once you really understand motion, you start seeing it everywhere.
Thanks for joining us on this journey through the science of motion. Keep observing, keep asking questions, and keep moving forward.
This has been another episode of the Akbar Academy podcast, where we explore the science behind the scenes of our everyday lives. Because at Akbar Academy, we're a class above the rest.